to see in the wild was Steam Add Remote Gameplay. Now granted, that's not a pure cloud solution because you have users' own Steam account and machines in their local network providing remote gameplay. But when we saw that launch, the response was really good. People actually didn't realize their own Steam games when they were hitting the Steam UI, right, to play a game. They didn't realize it was coming from another machine on their LAN. And that was very powerful. And of course, you have a case here with Steam having 1,200 plus games supporting Linux, Mac, PC, of course, and now SteamOS. It's a really interesting way to look at user behavior and how users felt about having this feature in the wild. And there's, of course, 70 million plus Steam users. And so we did pay close attention to that, and I think people really like that feature. And I think that bodes well for where this could lead if you take that to the cloud. And I think Steam in the cloud is definitely going to happen at some point. We were really just performing an experiment on Amazon this year with the Omnis. But I do think that is one really interesting venue for game publishers to explore. As I said, we did sort of test the waters with Autodesk and Mozilla and Amazon. The Mozilla part was interesting because for us it was the first time we were able to test pretty much everywhere JavaScript streaming. So there was zero client, absolutely no barrier to entry, and it proved very popular. It was something that really allowed, a lot of people came to us and said, we just want to host our app in the cloud, we want to have our games in the cloud, our platform, our store. And we like the idea that there is no friction, there's no app to install, and we have that working pretty much for a year now. And the next step is going to be to get this running on iOS Safari and on other mobile browsers so that you actually can deploy content and not just leverage all the things we know that are great about cloud gaming, but also just bypass the App Store model. That's something that the web allows, and that's one of the main reasons why we developed Orbex.js, which is this JavaScript library that decodes really fast, actually. So this is an example that we did when we launched. It's running Steam in Firefox on my MacBook at 60 hertz. And you can, the bit rate is about 10 megabits, but that's for 1080p 60. And the decode time of JavaScript is 8 to 12 milliseconds, which is pretty good for a virtual machine with no plugins, with nothing. We're working very closely with Mozilla and some guys at Google and even the IE11 team to let them know how we did this, to add things like UDP and other technologies that will enable the web to really become a very powerful endpoint. But even this is pretty cool. 1080p 60 in the browser, that's pretty nice. And that's available for free on Amazon with our virtual machines. I think that as we look ahead and think about what's going to really impact us, I would say it's really interesting to sort of see the evolution of mobile GPUs and set-top box GPUs because really they're starting to share the same parts. You're going to see Android TV boxes that come out with the same chips that are going to go inside the Samsung Galaxy Note, right? So there's a lot of cross-pollination between what's coming out for mobile and what's going to be on a set-top box. But what I think, and I touched on this in the keynote last year, you're starting to see a whole plethora of erosion, right, between what used to be the thin client in the cloud. So, case in point, when OnLive launched with their games in 2010, that was DX10 only. And now you have mobile phones that have DX11. You have web browsers with WebGL2 that has compute shaders, just like DX11 does. So it's really kind of pushing more pressure towards finding novel features, I think, for cloud gaming versus just play shifting, because really you're competing against almost the same experience for casual games on a mobile device, at least more modern ones. And that's going to be true of set-top boxes and smart TVs as well. And I think that, to be very honest, one of the really interesting inflection points we saw was iOS 8. You have this API, Metal, which exposes compute shaders, really low-level stuff that you'd expect to find in Mantle or DX12. And this is not in OS X. It's not in OpenGL, even on the new one that's coming out, 10.10. So here, Apple is actually enabling more power and more features and more advanced graphics on their mobile devices than they are on the desktop operating system. So that's really interesting. And I think that really the future for cloud gaming is probably going to have to take this into account. So that's why we see a big push, I think, especially as developers start really thinking about the cloud more seriously, towards hybrid games, where you actually don't ignore the fact that there's a very powerful GPU on the client, but you still do stuff in the cloud, and possibly mixed models are going to be really where things go, kind of, I think, coalesce for a lot of cloud gaming platforms that are looking to sort of maximize the efficiency that you get from the stream. The other thing that's huge, and this was just announced yesterday, but we've been sort of in on it for a while, working with Oculus on this product, and sort of getting our technology working on it, is the Samsung Gear VR. We announced yesterday, and I don't know how many of you have tried it, but if you haven't, you should. It changed everything for me. I mean, I tried the DK1, the DK2, but when I tried this, it just blew my mind, because you have a mobile phone that is going to be in the hands of tens of millions, maybe 100 million people. The use case for this, of course, is, well, you already have a mobile device, but with a fairly inexpensive piece of hardware. And Google's doing something similar, like they have cardboard. It doesn't work as well as this, but when you get this device, it's incredible. I mean, it is better than the desktop Oculus, and that means a lot for gaming, right? And it's a whole different set of problems when you're trying to get applications running on mobile VR than desktop VR. And I think that's where cloud gaming can really solve a lot of these problems. And so I'll sort of touch on that technology and how we've sort of been addressing this a little bit later. But this is definitely something that, for us, changes things. And if you look at the big picture, you have Samsung and Facebook partnering together. Obviously, Facebook bought Oculus because they felt this would be a new platform. They did it for $2 billion. That's not a small sum of money. And I think this is going to be a real game changer. If you, my clicker isn't working. Just to sort of touch back on Google Cardboard, the team working on it is taking that seriously. It is not a joke, even though it sort of was put out there as a lark at Google I/O. It is something they're putting serious efforts behind. And of course, Samsung and Facebook, Oculus basically worked for 18 months on the product that just launched yesterday. And so I think this is really going to be a big war between these two companies, because they're both fighting for the same thing, right? Access to users' eyeballs. And when you look at the models that cloud gaming has sort of been trying to solve with mobile, with set-top boxes, I mean, this is really a whole new arena. And I think it's really exciting for us to leverage, because it does provide a justification for cloud gaming that I don't think we had before, especially given the requirements of virtual reality on these mobile devices. So, next, I figured I would talk about our technology and how the things we're doing solve some of the problems and some of the opportunities that we see coming down the line. So Orbex is our streaming format, and we committed to open sourcing it, these decoder pieces, mainly to sort of get better cooperation from the web browser companies like Mozilla. And the JavaScript client is about to be updated. We're working very closely with Mozilla to time this with the WebGL 2 launch in the browsers. That will also be in Chrome. And Orbex 2, that codec, basically surpasses the bit rate of H.264 high profile, which is pretty good for a JavaScript codec. And as I was saying earlier, we're targeting this year getting this to work flawlessly on mobile browsers, on Android and iOS, and set-top boxes. And there are even smart TVs that use just the web. LG has WebOS, for example. And as we look towards new compression technology, HEVC is certainly one of them. That has great bit rate, but it's missing a number of things that frankly, even for video, are going to be important. Rec 2020 is the new ultra-high definition video format. It's designed to match what you get in the cinema, and you need 12 bits of color, and that's really a ways out for HEVC. There's also no support in either H.264 or HEVC for things like depth and coverage. And those things are really important for cloud gaming, especially the kinds of cloud gaming experiences that we're trying to build on our stack. Last year I teased a bit of technology that actually could change a lot of things for cloud gaming. We're adding it to our cloud platform. Basically what it does is called Orbex 3D, and instead of just streaming 2D video that's encoded from the back buffer of the game, it'll actually detour the DirectX or OpenGL draw commands and send them down to the client. And so we had this working with the X9 last year, and in the next few months we'll release a version that supports the X11, full shader Model 5, tessellation, compute, pretty much everything, if the client is able to do that. And then we'll have clients that will support everything pretty much. I mean, including HTML5 with WebGL, but also iOS, Android, and the like. And the reason why this technology is very interesting is that if you're interested in saving costs on the cloud, this is probably the best way to do it. You don't need any GPU on the server. You can just just run as many games as you can on a CPU. It could be a very cheap Amazon instance, for example. And you know, if the game detects that the client has DX9, DX11, some sort of GPU, and frankly, most web browsers and mobile devices do, right? That's one of the trends that we were focused on. Then you can actually do this remote stream. The remote stream is maybe 3 megabits, 5 megabits, but there's no resolution. And ultimately, if you're doing things that are local, it also doesn't have any latency. And the way that we see this technology working in the future is not just with allowing the game, when it can, to stream with just the drop commands to the client and make cloud gaming cheaper, but also enable things like hybrid gaming, where some of the rendering is done locally, some of it's done in the cloud. And in order to make that really work, we have to be able to basically place shift the drop commands through DirectX or OpenGL onto the client, and then create tools for developers to then split that, right? Some can be done in the cloud, some will be done locally. Basically, automatically in our system, it's either or, right? DX11 or DX9 gets sent down to the client if bandwidth is X amount and the client has a certain GPU. But this is really cool. And we're building a lot of these different siloed technologies to be mixed together by developers, game publishers, anyone that is using these technologies to improve the cloud gaming stack. The next bit of tech that we've been working on in the last 6 months is pretty cool. If this clicker doesn't work, you may want to advance to the next frame. So it's called holographic video. It's not really a hologram, it's actually technically a light field. And light field is an interesting type of format. I mean, it simulates what a hologram looks like. So if you think of stereo 3D, you get left and right views. A light field is all of these, right? If you're familiar with Lightro, you can do things like redo depth of field after you take the picture. The way we're doing light fields is much more about capturing a big giant volume and streaming that volume, that cube, basically down to the client. The reason why we went ahead and did this technology now versus a year from now or 2 years was largely because of John Carmack, who's the CTO of Oculus, and his influence on this industry is huge. I mean, he can just Apple use OpenGL. That's pretty much changed our industry, right? Cloud to local. And so he was interested in our work in this space and encouraged us to really get it going this year. And of course that has sort of timed itself perfectly with the release of mobile VR, right, with the Samsung Oculus device that we were just discussing. And I think that it's not just to deliver a good mobile VR experience that we're developing this technology, it's also to solve a lot of the problems just in general with cloud gaming. I guess
I'm going to cross down to our first interview on the show floor. It's with Otoy, and this is my kind of favourite tech. I even told you that's my favourite tech from the show. It is such a mind-bending thing. I'm going to have to even set this up for you. Just to explain, this is probably an end-game solution for a virtual VR helmet kind of Ocular Rift kind of thing. But even without that, it actually works incredibly well. But when looking at it, it looks like we've either canned the demo or it's somehow been pre-rendered and we're just faking it out or whatever, but I can promise it's all interactive. It has the illusion that you're rendering in real time, absolutely ray traced, photorealistically a street, and that you can look at it from any angle and that you can move anywhere you want. Now, of course, we can't render that fast. Like, no one can render that fast. Even the best preview renderers can't do the kind of levels that we're talking about, and yet this is running on incredibly sort of quick, not very expensive hardware, because it's not a very expensive process at the final stage. And so I'm looking at this and I'm going, John, this breaks a couple of laws of physics. Well, it's basically built on light field technology, and light field stuff is some stuff that you might know, I love to death. So I went and spoke to the guys at Otoy who have come up with this technology. It's really revolutionary, and I've got to say, a number of people are looking at it. So hopefully you'll be able to piece it together, because I can do as good a job as I can of explaining it when you actually see the footage and hear how they basically came to put these algorithms together. So thanks for joining us, really appreciate it. I'm incredibly impressed by, I guess I'm calling it the holographic display technology. You're calling it light field. What is it that I'm impressed with?
Well, it's both. Light field is a more technical term for holograms, but I think most people are familiar with the holodeck, and that's why in sort of popular culture, when people see something like this, they think of holography. But the idea is that with a single frame of this video, you're able to look around the scene. It's perfect for things like VR. And we're really trying to build a holodeck. I mean, that is the goal of what this technology is designed to provide. This is the first step. So when you get an Orbex holographic video stream, you are able to fully navigate through an environment. It looks completely real, and it decodes on any device, including a mobile phone. And 2D image is a pre-rendered snapshot of a point in space. So what we're doing is we're extending that into a volume, and within that cube, you can walk around, and it is like a living photograph. That experience is what this delivers, and we do actually solve those two problems. We can also render the scene in real time without making it into a hologram, but that is more expensive. It requires a lot of graphics cards, and there is some noise. So this gets rid of that, turns it into a volume that is largely static, but can also have motion. We can relight it. There's certain things you can still do with it, and then you have the full. It's even faster than rendering a video game or rasterization based application using OpenGL or DirectX. It's super fast. So it decodes at about 1,000 frames a second, which is perfect for VR where you want to have very low latency and very fast refresh.
That was 1,000 frames a second you just said.
Yeah, it's a millisecond.
Okay, so you gotta tell me, why did they have it hidden? Because you told me to go over there, and Ian and I couldn't find it. We were mesmerized by the portable light stage.
Yeah, there was portable light stage, this rack of monitors, and then down on this coffee table, you'd think it would be like where people checking their email, is this technology that honestly a whole lot of us, I'm not the only one, thought, oh my god, this is a really revolutionary way to break through. And not only that, just to be really clear about it, while we were moving around a still frame, this could be an animation. You could have the bat car drive up and screech to a halt, and I'd be able to be moving around in it, because all it's doing is updating each light field per frame, and that would have been pre-rendered effectively, but it's not a render. Anyway, very cool tech.
So that was sort of a primer on what this does. How to apply to cloud gaming is really interesting. We can also generate these light fields live. So we can have, just like we're doing tricks where we're taking the DirectX or OpenGL draw commands, sending those down to the client, we can also generate a light field from that very same set of data. And it's not very expensive. I mean, the stuff we're showing here is full path tracing. It's using hundreds of GPUs on Amazon to give you this in real time as a preview tool, and then the light field is giving you that in real time after the fact, with some sort of static scene environment and animation. But you can drive a full game with this technology, and we're making that experimental test with game engines like Unreal. So we're partnering with Epic on a number of fronts, and one of them is to get this light field technology inside of the Unreal Engine in the cloud. And the first use case will be that you'll be able to render a lot more Unreal game engine streams on the cloud by having the entire environment stored as a light field, right? It decodes super fast, and the quality is perfect. So there's no need to use the X11 for an environment when you have this technology. The entire art pipeline, we figured out, right? We have tools for 25 different apps, including Photoshop, of course, all the Autodesk tools. So the pipeline for next-gen cloud gaming is something like this. And this is a cool technology because it takes all the work we've been doing for high-end rendering and makes it usable both on the cloud and even for local rendering, in a way that suits cloud gaming really nicely. This is actually, again, just one frame. So imagine a cloud gaming stream, right? It's just one frame where it's just static. That one frame of a light field video, you can look around for 2 minutes without downloading another frame. So that's why this technology is pretty useful for things where you have a bad network connection, right? If one frame can actually be stored and give you essentially a window into that scene all around you, then you don't really need more data from the cloud. So that's the kind of streams that we're looking to build with this tech. And it does need to be integrated in next-gen games, but then again, Unreal Engine 4 and some of the other engines we're working with will be able to do that pretty much automatically. A little bit of technical background. Again, we have depth information. That allows us to actually repurpose the stream very easily with the time warping that Oculus uses on their VR devices, both mobile and desktop. It's a simple OpenGL. It has pixel shader that does both the rendering and the decoding. And the rendering portion from the light field is 1 millisecond. If you step back a little bit and think about how this works, of course, outside of VR, essentially a light field stream means that the camera view can be changed locally with 0 latency while the cloud is rendering that scene. And it doesn't have to be at this very high quality. It can just be typical DX11 on max settings. That's a little bit less than what we're doing with our ray tracing technology. And again, we're using Unreal Engine 4 as a template, as a test bed really, to see how it works. There's tons of developers now on Unreal Engine 4, largely because it's really pretty, and of course you have the source code. It's also been easy for us to take the source code and start adding our pieces into it, including not just this light field stuff, but our high-end ray tracing technology, which is called Octane, and we have another one called Brigade that's more for games. And I'll sort of touch on those at the very end. The light field technology, again, is something that we're releasing in the next few months on the cloud. And yeah, we expect that there'll be a lot of interest, especially for developers targeting VR. And again, I highly recommend anybody that hasn't tried the Samsung VR device, give it a whirl if you can. It'll be out by the end of the year. And it's essentially going to be Oculus's first consumer device, which is pretty exciting. Next slide, please. This is working, so I'm going to speak forward to the next. Oh, I guess now it's working. So
you have an amazing desktop application. Trouble is, it's only on the desktop, and your competition, they're in the cloud. So basically, your amazing software is consistently losing out to inferior products, and this just, well, sucks for business. Wouldn't it be great if you could just take your application and put it everywhere? Well, now you can with X.io, offering Windows desktop applications just like yours, the ability to stream seamlessly from the cloud, with no drop in performance or any major application redevelopment required. It's as simple as signing up, uploading your software, and pasting a line of code in your site. Just like that, your potential market share has expanded, big time. You also won't have to worry about juggling different versions for your users. Update your software in the cloud, and it's updated, period. Our web-based management portal allows you to upload and manage your apps 24/7, 365. And when it comes to control, the X.io APIs and SDKs give you all you need to enable whatever your requirements might be. You can do all of this and more without any real changes to your application. As for your users, no lengthy downloads or installs are required. Streams run right from JavaScript. All they have to do is click a button. And with data centers around the world, streaming is always super responsive. It's a ridiculously easy process, requires very little work, and offers a potentially gigantic payoff. It's time to get your application in the cloud with X.io. Go to X.io and fill in your email address to be the first to hear about the launch.
So the video that I had, but X.io is really cool. We created the service out of our research that we did launching these free virtual machines on Amazon with our JavaScript codec. We got a lot of feedback, a lot of people wanted to use it, and the things that were missing from Amazon even, we felt we needed to add, and we really wanted to make the process simple. And that's where X.io sort of came in, right? I mean, people want a one-click solution, version control, they want to find the cheapest instance. Most importantly, they just want a cheap streaming solution, and it's hard to do that if you're one publisher, one developer on Amazon, and you don't have a lot of scalability. And so X.io has a couple of goals. First of all, yes, making everything easy in one click and making it dead simple to sort of rebuild a lot of the management tools that you would need to make a deployment available globally and have very little or no code changes needed. All of that's built into the system. But what's interesting for us is that we're targeting a lot of different things with X.io. So it's not just applications, as we touched on in that video. It's also gaming and even compute and render. And the reason why we're creating this sort of blended service is that the more users and the more partners we get using the service, as opposed to just individually booting up an Amazon instance, the easier it is for us to then get cheaper pricing on Amazon. So we can start using that scale to get reserved instance pricing, respond instance pricing. That's really impossible to do if you're running a cloud gaming service on Amazon and your reserved instances start to, they're not really being used when people are sleeping. So what we do is we'll buy up all those reserved instances, we'll find something that runs them 24/7, and X.io is really just, like the name implies, just input output. You just run whatever you want on it. Cloud gaming is just one endpoint, one part of that spectrum. But it allows us to pretty much provide a library, SDK, and web page where you can just leverage that scale on top of Amazon to provide cheap game streams. And the other thing that we've done on top of Amazon is added permanent pricing, which a lot of people wanted, and cleanup and virtualization is all handled behind the scenes. There's a web console, gives you analytics, gives you everything you want to know about your customers. And within the X.io stream, all of this technology that I just showed you, Vortex, the light fields, the extra moding, is built in. So you have all that in addition to the JavaScript codec and other pieces that are going to be added as we keep working on the technology. The other thing that we wanted to accomplish with XIO was to add the ability for others to build on this, right? So XIO was really a step. I mean, we're not Amazon, we don't build these servers. We could, and in the past we've tried that, but what we're trying to do is actually come up with a standardized way of putting this XIO stack with everything, the ability to run rendering, games, and all the things that we discussed inside of a box that we can then lease to others that want to basically have their own data centers or want to build their own cloud gaming service in-house. And we're also using that same sort of that same layer to provide offices and render farms the same capability. But we've come up with a pretty good pricing model around leasing these boxes with our software installed. And so we have 8 and 16 GPU appliances that are powered by both AMD or NVIDIA cards, starting at €2,400 a month, which is pretty good. And I think the leasing model is a really interesting one because it allows us to sort of test the waters at a small scale with different partners. And the idea is that the leasing model with these boxes allows you to create a differentiating factor from what the big guys can do, such as Amazon. So going forward, a big part of what we, sort of tying all these things together, what we want to do in XIO is provide totally new features that change the way that cloud gaming works, and even rendering and even applications. But I think rendering is a big part of our DNA as a company. Otoy is really a cloud graphics company, and I think if we're going to do our job right, we have to find a way to replace and build, a suite of tools and technology that takes us beyond DirectX and OpenGL, which have been around for a very long time, but are sort of showing their age. They weren't designed for the cloud. They weren't designed for ultra high-end graphics. They weren't designed for CG quality film graphics. So that's where Optane and Brigade come in. We built an entire tool pipeline around Optane. It's been out on the market for a couple of years. And most recently we added this interchange format. It's the OrbX file system that allows you to actually export the entire scene with all the lighting, all the animation, even physics now, from any application, including Max or Maya or Unreal, and you can use that as an interchange format, which is great. It's never been done before, so that's pretty novel. But what it also allows us to do is to create new types of applications that can take those scenes and then do different things with them. And so that's what we're building into the Unreal Engine, and we're using basically this OrbX scene file to generate light fields to provide essentially a equivalent to DirectX and OpenGL that is purely based on ray tracing. And in the cloud, that makes a lot of sense, and especially on Amazon or on these XIO boxes, we can make that very cost effective. And it's not just for rendering, we're also working very closely with companies like Pixelux that create the physics and the force unleash. We want to have that entire pipeline built into the OrbX scene file that also is basically open source. And if people aren't familiar with Brigade or Optane, I guess it's worth sort of showing how they work. Here we go. So this is Brigade. This is running on basically on 2 780s. And it's entirely ray traced. So the reflections, the lighting, everything is dynamic. There's nothing that's baked. This is in stark contrast even to things like the Unreal Engine or Lighten that's used in Unity, where there has to be some sort of pre-processing. This is completely live ray trace rendering. And the noise is something that we're working on reducing. That's going to be the last step before we release Brigade out to the wild. But with that last piece in place, you can basically use this instead of DX or GL. And to make it even simpler, we're adding this, this render and our other rendering technology to Unreal. And then we're providing an SDK for other game engines to basically enable this. And we're going to work very hard to make it so that it's redistributable and free. But ultimately, this is going to be something that, while it may be great for high-end PC gaming, it's going to be awesome in the cloud. And it connects very deeply to all the stuff we were showing before with the light field streams, with depth channel encoding. There's a lot that we can do when we are controlling and enabling a whole new type of rendering system designed for the cloud, designed for remoting. And existing solutions that take DX or GL, send them to an H.264 encoder, will only get you so far, especially as you start to think about things like VR, where that won't even work. You need to come up with something different if you're going to be doing cloud gaming on a virtual reality device, whether it's mobile or desktop. Going forward, even further down the line, really, we just need to enable a graphics pipeline that looks completely real. I mean, that's what the promise of VR is meant to deliver. If frankly, gaming that's designed for photorealism, and a lot of games are, high-end games are, they need this. So we've pretty much taken Brigade as one step towards that process, but Octane is our ultimate renderer that's used for films now, but we're making it essentially another layer that we can plug into game engines like Unreal. And so we just announced that at SIGGRAPH just a few weeks ago. And I have a quick demonstration I can show you guys. So this is Brigade, and Octane is essentially very similar. So this scene, you'll see in the next slide, is loaded in the Unreal Editor, and we have the ability to basically have Unreal drive this with any game content that you want. So that's basically the output path, and the developer, the game creator, actually sees this rendered viewport as they're building the scene or designing the game. And of course, the game, when it's published on the cloud, has this kind of rendering power readily available. This requires more than one GPU. You need 4. But then again, you can probably build a premium experience around this. And given that a user doesn't have to buy a $1,000 GPU, much less 4 of them, there are some really interesting business models that can be built with really going beyond DX11 and just going straight to path tracing. And it's very fast, as you can see the Unreal window and the path trace viewport that we're replacing with DX and our ray tracer work at exactly the same speed. So you don't lose any interactivity or flexibility. You just get better rendering quality. And this is a great example of how. So this is Octane. This is our highest end renderer. If you saw the earlier video, we turned this into a hologram so that we could go through the scene and do it live without having to, render it out fine. But with the light field technology, these scenes and even these animations can be leveraged for cloud gaming in the next few months. And I think even for high-end films, this is actually really high quality. A lot of films don't even render things like caustics or proper deformable motion blur, and all these things are built into our stack. So I think this gives you guys a taste of where we're aiming for and what we're trying to accomplish with all these new graphics tools. And I think that when cloud gaming reaches this level, and I think it will pretty soon, at reasonable cost, things will be really different. And VR and mobile, and of course what's happening in the living room with different set-top boxes now that are essentially meeting Android devices or web browsers. There's a lot of endpoints that we can connect all this to. So that's it. Thank you very much. I don't know if there's any questions. I'd be happy to field any if there are. Yes?
So you talked about the DX and GL remoting, like just the documents to the client. So some games, like high-end games, like they might upload like a gigabyte of textures to the PC graphics card. So how much of, like I'm curious how that plays out on a mobile device that doesn't have that much.
It doesn't. It's a very good question, and there's also another thing that doesn't work with it. If you need to touch the vertex buffer, for example, that can be a problem. So it's probably very useful for casual games. It can be used if you design your game with it in mind, because we actually do encode textures and decode them transparently behind the scenes, so that might answer one of your questions. That's why we have a GPU encoder and a GPU decoder for our codec. But typically a game that is, with basically no download could run pretty well with this, and we've tried with things like Dota 2, for example. It works really nicely there. So it's not necessarily used in every case. It's why it's just one option. And the simplest answer is if it doesn't work or it takes too long, then you just fall back to pure remoting or some of these other options that we're also adding into the mix. Yes?
Yeah, I mean, everywhere I see this, and it's a little more incredible. Each year, you show this video, and I go, oh, okay. Where do you think most people are going to experience this? Oh, sorry. I guess my question really is, where do you think most people are going to experience this for the first time? Like, what's going to be the reduced friction point, whether it be in goggles or at an event location? Where do you sort of see this, do you think, a year ahead?
That I just showed at the very end of that truck moving through the scene, I mean, we're building this for the Samsung VR device. And that's going to be one of our targets. So that device, that endpoint, that market is going to be one really where this high-end cloud gaming actually, without it, you don't have it, you can't have that experience on that device. There's cloud gaming is always fighting against the fact that you just need to download the game, run it locally, right? I mean, we deliver experiences that are just impossible on a device that's going to be selling tens of millions of units and perhaps surpassing even console sales. That's, I think, where this is going to be really useful, and we're definitely targeting that this year. So that device is launching this year, and we want to have all this ready by the time that it's consumers' hands. Yes.
What
happens if something changes in the light field, like you interact and there's an explosion, do you refresh it, or what happens?
Sorry, Phil, I think I couldn't quite hear the question. Maybe.
Just gonna ask, what happens if something changes in the light field? Like you interact with the scene and there's an explosion, do you refresh it at that point?
So the one thing I didn't touch on about the light field streams is that they contain all the basis lighting conditions, just like the light stage. In fact, that's kind of where a lot of this came from. So you can do relighting and you can also reproject lighting onto the light field. So you have depth data normals and basically the equivalent of 156 different lighting bases for like stroke or lines. So that allows you to relight the scene and cast shadows. And the other thing we can do is we can also separate every single element of that light field into component parts. The codec is not strict about that. We can have auxiliary layers, you can take out the Batmobile, you can swap it out, you can actually do all those things. There are limits, but they're really not much, they're actually less hard than the limits you have when you're baking a scene in the Unreal Editor. So that's kind of where we see light fields really being useful, is in environments particularly where the scene is just massive and the lighting needs to be perfect. What I think could be useful is you take that Orbex 3D stream and you're streaming down a DX11 character that's close to the camera or anything in the near field, and you mix that with light fields. That's really powerful. So that's the kind of stuff where interactive gaming could probably make use of the light field stuff right away. Of course, you can also just use that in the cloud, as I said, just to replace doing light baking in with rasterization. You just use a light field as as a scene, and then you can still do really good shadows and simulating with the data that's already exported from Octane. That's light field.